Hello students. So in the last lecture I was discussing about the memory organization of 8051 microcontroller. I discussed the program memory organization of 8051 microcontroller and I started the data memory organization of 8051 microcontroller. And in data memory organization I told you that 8051 microcontroller has 128 bytes of on-chip RAM, and this 128 bytes is further divided into three parts. This is the register bank area. The first 32 bytes of 128 byte is covered, or it is occupied by the registered banks. The next 16 bytes is occupied by bit addressable memory, and the last 80 bytes is occupied by general purpose memory or scratch pad memory. And there I also discussed about that in the register bank area we have four banks. There are four banks, and each bank is consisting of 8 registers. As you can see, each bank is consisting of 8 registers. So this is a more clear picture. You can understand that this is the register bank area, this is the 16 byte bit addressable area, and this is the scratch pad or general purpose area. This whole is 128 bytes of on-chip RAM of 8051 microcontroller. So this is the register bank area. The register bank area is further divided into four banks: bank 0, bank 1, bank 2 and bank 3. Each bank is having 8 registers which is designated as R0, R1, R2, R3, R4, R5, R6 and R7. So each bank has 8 registers. As you can see, bank 0 has 8 register, bank 1 has 8 register designated as R0 to R7, then bank 2 has 8 registers designated as R0 to R7, and bank 3 has 8 registers designated as R0 to R7. So each bank has 8 registers. These registers are obviously of 8 bits. Now these registers, they have been designated as R0 to R7, whereas the registers also have addresses. Here you can see 00, 01, 02, 03. So these are the addresses. These are the addresses of the registers. So as I've told you that the register bank area extends from 00H to 1FH, that is constituting 32 bytes. So this addresses are given to these 32 working registers. These are the 32 working registers. Each bank is having 8 registers, so 4 banks will have all total of 32 registers, and each register has the address as well as each register has the name. So now we can address, or we can address the register. There are two ways of addressing these registers, that is one by their name or by their address. Now if I want to address the register by their name, so as you can see, bank 0 has the register R0 to R7, bank 1 has the register R0 to R7, bank 2, bank 3, similarly for bank 2 and bank 3. So if I'm addressing the register by its name, suppose if I'm writing R3, so how will I know which bank register I'm actually accessing or I'm addressing? Because every bank is having the register with the designation R3. Every 4 bank is having the register with the designation R3. So if I'm going to address the register by its name, I should be clear about which bank register I'm going to address. So for that, the particular bank has to be selected. So there are 4 banks, and from these 4 banks only one bank is active at a time, or only one bank can be selected. And how it can be selected? Through the program status word register. I'll be telling you. So again I am repeating, what I am doing is, here if I have to address the 32 working registers, if any one of the 32 working register by its name means R0, R1, R2, R3, R4, R5, R6, R7, this name. So if I have to address a particular register from among this 32 working register by its name, the first step is I have to select the bank, and the bank can be selected by the program status word register. So this is a special function register. In inside 8051 microcontroller there are set of special function registers, and among those special function register, one register is program status word. So this is program status word is a 8-bit register. This is a, as you can see, this is a 8-bit register, 1 2 3 4 5 6 7 8. So this is a 8-bit register, and in the 8-bit program status word register, the third bit and fourth bit of program status word is used for selecting the registered banks of the RAM of 8051 microcontroller. So the third and the fourth bit of program status word is used for selecting a particular bank from the 4 banks. So this has been designated, third bit has been designated as RS0, the fourth bit of program status word has been designated as RS1. So by default, because initially they both are 0 0 only, so by default bank 0 is selected, and if I have to select any other bank like bank 1, bank 2 and bank 3, I have to make the particular bit 1, or I have to set the particular bit 1. So SETB, set bit, SETB and CLR commands, these are two commands, these are the commands that are used for changing the bit values of RS1 and RS0. For example, if I write the instruction set B PSW.3. What does it mean? I am setting the third bit of program status word, that is I am making the third bit of program status word to be 1. So what is the third bit? It is the RS0, it is designated as RS0. So if I make the third bit of program status word to be 1 while making the RS1 to be, while letting the RS1 to be 0 only, so this means bank 1 is selected. So initially RS0 and RS1 are at 0 0, means bank 0 is selected by default, and if I have to select any other bank, so I have to use this commands like set B and CLR is for clearing the bit. I have to use this command for setting the bit of PSW. So in this way, these are the various status of RS0 and RS1. Depending on the status of RS0 and RS1, the particular bank gets selected, and if the particular bank gets selected, suppose bank 2 gets selected. So suppose if the program status words, the third and fourth bit of program status word, the status are 1 0, so this means bank 2 is selected, and if the bank 2 gets selected, and if I am addressing R5, means R5 of bank 2 will get selected. So the register that is having the name R5 of bank 2 gets selected. So this is the procedure. If I have to address the 32 working registers of bank by their name, if I have to address these registers by their name, first I have to select the particular bank by using the program status word third and fourth bit, and the particular bank gets selected, and then only I can address the register by its name. Now when addressing the register using its address, if I want to address this registers by their address, I can also address it by their address, and for this bank may or may not be selected. It is not a mandatory criteria for the bank to be get selected if I have to address the register by its address, because for example if I am writing 12H, so 12H, what does it mean? 12H is corresponding to this register, R2 register of bank 2. So the address is itself telling me which register. So if I have to address any of the register by their addresses, so I will directly write their address. There is no need of selecting the bank. This is not a mandatory criteria for selecting the bank. So this was about the register bank area. The next part of the 128 bytes of RAM that I am going to discuss is the bit addressable. This is the bit addressable area. So this bit addressable area is of 16 bytes. As you can see, there are 16 locations, and each location is 1 byte, that is of 8 bits. 1 byte means 8 bits. So a more clear picture you can get to see here. So this is here I've shown two pictures. This both the pictures are bit addressable memory area pictures only. So these are the 16 bytes bit addressable memory area, because as you can see there are 16 addresses and each address is having 8 bits. So this, as you can see, if this is 20H is the address, it is of 8 bits. So each bit of each address is given the addresses also. For example, here you can see in this picture 20H, since this is of 8 bits, each bit is given or assigned an address like 00, 01, 02, 03, 04, 05, 06, 07. Then again 21H is also of 8 bits, so every bit has been assigned an address. Since it is 07H, the next address that I'll assign to the first bit of 21H is 08. So 08, 09, 010, 011, 12 up to 0FH. In this way, every 16 bit, or you can say every 16 bit, every 16 addresses will have 8 bits. Every 16 addresses will have 8 bits, and every 8 bit will be assigned an address. So in this way, there are all total 128 bits. How 128? Because one address is having 8 bits. So there are 16 addresses. So for 16 addresses, how many bits? 16 into 8, that is of 128 bits. So every 128 bit is having an address. So that's why this memory is called as bit addressable memory. Bit addressable memory. Why? Because we can address individual bits also. One bit. We can address individual bits also. So this 128 bits can be individually bit addressed starting from 00H to 7FH, or we have an option, we can directly use this memory for byte addressable. We can directly address it using byte, like 20H to 2FH. So this memory, it can be byte addressable, like we can write the directly write the byte address like 20H or 21H or 22H. So directly byte addressable, or it is bit addressable also, because we can address the individual bits by their addresses. Now these bits can also be modified using setb and clrb commands. For example, here I have shown one example like CLR0FH. So basically setb and CLR are used for setting or clearing the bits only, one bit only. Okay? So for example, CLR0FH, since CLR is used, means it is addressing the bit. So the bit that is having the address 0F will be cleared. So 0F is which bit? 0F is the last or the 7th bit of 21H. This is the bit addressable memory, that is the 16-bit bit addressable memory of 128 bytes of RAM, 128 bytes of RAM. So 0F is the 7th bit of 21H address. So D7 bit of RAM location 21H will get 0. Again, if I am writing set B42H, so set B42H, again you can see every bit is having the address, and if you see this 40, 41, 42, so 42 will be the second bit, like D0, D1, D2, second D2 bit of this 28 memory location of the RAM. 28H memory location of the RAM, that is 28H memory location of bit addressable memory of 128 bytes of RAM. The D2 bit of this memory will get set. So this is how this bit addressable memory is. Now, this was about the bit addressable memory. The final 80 bytes of internal RAM, as I've told you here also, the final 80 bytes having the address from 30H to 7FH. So the final 80 bytes of internal RAM, that is from address 30H to 7FH, is the general purpose RAM area, which are byte addressable. Means we cannot address the bits, we have to use this memory in the form of bytes only. We can address the bytes only, whereas this bit addressable memory can be accessed in the form of bytes. We can use the 8-bit register, or we can individually use the bits also, that is bit addressable and byte addressable, whereas scratchpad memory is only byte addressable. So you may read or write a full byte data at these locations. Now, this was about the 128 bytes of RAM having the address from 00H to 7FH. Now, above 7FH, that is the upper 128 bytes, that is addresses from 80H to FFH, is allocated for special function registers. When I was discussing the program status word, I told you that 8051 microcontroller has a set of special function registers, and program status word is among them only. So I'll be discussing the special function registers when I'll be discussing the architecture part more clearly. So here you just understand this 80H to FFH, this upper 128 bytes is occupied by the special function registers. So the special function registers control specific functions of the 8051 microcontroller, and these addresses are above 80H. These addresses are above 80H. Why? Because the address 00H to 7FH are addresses of RAM memory. These are the addresses of RAM memory. That's why from 80H the address for special function register is starting. So not all the address space of 80H to FFH is used by special function register. The unused locations of 80H to FFH are reserved and must not be used by the 8051 microcontroller. So some of the special function registers are like program status word, then accumulator, then interrupt enable, input output port register. So I'll be discussing about all these registers in detail when I'll be discussing the architecture part of 8051 microcontroller. Now 8051, this was about the 128 bytes of RAM. Now 8051 also supports 64 kilobytes of external data memory in addition to this 128 bytes of internal RAM or on-chip RAM. So this external data memory is accessed using 16-bit address lines, and therefore its address varies from 0000H to FFFFH. So this is the 64 kilobytes of external data memory. This is the 128 bytes of on-chip RAM. So this was all about the memory organization of 8051 microcontroller. In the next lecture, I will be discussing about the architecture of 8051 microcontroller. I am ending this class here. Thank you.